All right, we're diving into lesson 5 now, volumes by cross sections. We're going to find volumes of three-dimensional shapes where we can slice them into geometric shapes like squares, triangles, semicircles, rectangles, different shapes like that. To do this, first we need to remember what our formulas are from geometry class. So first up we have our square. If we have a side B, the area is going to be just B squared. A rectangle, if it has a height equal to 1/2 of B, then our area is going to be 1/2 B squared. Okay, so this side right here is half of B. If this was something else, like A, it would just be A times B. A semicircle, if radius is going to be half of B, right? So R is 1/2 B. That means we can write the area as pi over 2 times B over 2 squared. So these are some fancy versions. If this is confusing for you, think about what just regular area of a circle is. It's pi r squared, and we would multiply that all by 1/2 because it's a semicircle. Isosceles right triangle with a base as a leg. So an isosceles right triangle means the two sides are the same length. So this side is also B. Remember, a triangle is 1/2 the base times the height. So amazingly enough, our area here is 1/2 B squared. Let's see, isosceles right triangle with hypotenuse as the leg. Well, we have, again, we have the height is 1/2 of B. That's right in here. So then our area is going to be 1/2 B times 1/2 B, which is just 1/4 B squared. So again, you know what area of a triangle is. It's 1/2 the base times the height. We're just looking at what if we're given something a little bit different. All right? She's trying to show us some shortcuts in here. Equilateral triangle. Well, that means that we have our height coming down here. This would be a 60-degree angle. So this is a 30, 60, 90 triangle. So if this is H, this is 1/2 B. That means that our height is going to be square root of 3 over 2 times B. So our area is going to be 1/2 B times the square root of 3 over 2 B. So when we simplify that down a little bit, we get square root of 3 over 4 B squared. Now, if any of these things are confusing to you, just keep in mind that you can just use the straight up regular formulas for rectangle and semicircle, and then just use some logical reasoning to figure out, well, if I know this side is half of this side, what is my area going to look like? All right, so don't be afraid to use the basics of what you know and then reason through that to figure out what the area is going to be. So these are just trying to get you to think a little bit outside the box with the area formulas. Cool. So at the bottom we talk about cross sections of an area A taken perpendicular to an axis. So the cross section needs to be perpendicular to the axis. So the cross sections that I showed you earlier, they're going perpendicular to a particular axis. So cross sections taken perpendicular to x-axis are going to be this one right here. Notice we're doing it with respect to x. If they're perpendicular to the y-axis, then they're done with respect to y. So if you want to go back and watch the other video on cross-sectionals where I showed you the ones the class made last year, you can go back and look at it real quick, watch a couple seconds, snippet of it, and see where those cross-sectionals perpendicular to x or y. And maybe you can even pause the video to look at some of the work they did from last year. Moving on to our examples. Example 1. So first of all, let's look at the function here. It's square root of x. They tell us our boundaries are this function, so that starts at 0 and it's going till 4 if I'm thinking about vertical rectangles. If I'm thinking about horizontal rectangles, I'm going from 0 up to 4 also. Awesome. So what we really need to pay attention to here, what we're going to really be integrating, is the shape that the cross-sectional is. In this case, it says the cross-section is a square taken perpendicular to the x-axis. So that means we're dealing with vertical cross-sections. I'm slicing it vertically like this. That means we're doing it with respect to x. So I need to know area of a square, and that's b squared or s side squared, however you want to write it. But what is the length of a side of my square? So each little line that I drew in here, these are little squares that are standing up, representing the three-dimensional shape, so they're standing up. If I'm looking at the length of my square, my length of the square, the height of the square, depends on my top function. So the height of my square is always going to be the square root of x. So really, my area is the side squared. So my integral for volume, when I'm integrating it, is going to be the square root of x squared. For bounds, since I'm doing vertical rectangles, my bounds start here and they end there, which means I'm going from 0 to 4. And all we have to do is integrate like we normally would, but I think maybe we want to simplify this before we integrate it, because if I'm squaring a square root, that means those two operations are going to cancel each other out. I'm going to get x dx. I like integrating that. That sounds easy. We're going to get 1/2 x squared from 0 to 4. And we're going to get 16 minus 0. And when I multiply that by 1/2, I'm going to get 8. So it's 8. And since we're talking about volume, our units are cubed.